Today our topic is graphing y equals a times the difference of x and p times the difference of x and q. So our learning target, how can I graph quadratic functions in intercept or factored form? Vocabulary, the graph of intercept form, which is y equals a times the difference of x and p times the difference of x and q. Characteristics of this graph. So if we look, this is in factored form, which we worked on in chapter 9. We call it intercept form because it gives us the x-intercepts. The intercepts are p and q. Now I really want you to notice subtraction signs, which means if you don't see subtraction signs, you're going to have to make subtraction signs. The axis of symmetry is halfway between your x-intercepts. So the axis of symmetry can be found by using this equation when it's in intercept form. The parabola opens up if a is greater than 0, so positive, and it opens down if a is less than 0, so negative. Jumping right into examples, graph the function y equals negative x plus 1 times the difference of x and 5. So first off, we're going to write the standard form above it. All right. A is negative 1, which means parabola is going to open down. P, if you see this, it says plus 1. It does not say minus 1, which means we need to write that as x minus a negative 1. Now it's minus a negative 1, which means p is negative 1. It's not positive 1, it is negative 1. That is going to be the one piece of this that might trip you up, so really be careful on that. Then x minus 5 is okay because it's minus, which means q is positive 5. All right, q and then p. It's different from that subtraction sign. Must have a subtraction sign before it, and then you take the number after the subtraction sign. So, identifying and plot the x-intercepts. Well, p is one of our x-intercepts, and q is our other x-intercept. Now, when we plot those go on our x-axis. So we have negative 1, 0, which is right here, and 5, 0, which is right there. Now we have our x-intercepts. We want to find and graph the line of symmetry. So our equation for this, when it's in intercept form, is x equals p plus q divided by 2. P is negative 1 plus q is 5 divided by 2. Negative 1 plus 5 is 4 divided by 2 is 2. So our line of symmetry is x equals 2. X equals 2 is right here. We draw the vertical line through that point. Now we have our line of symmetry. Find and plot the vertex. So the vertex is either your highest or lowest point, and it's always on this line of symmetry. So we know x equals 2. We need to figure out what y is. Use your equation. Y equals negative x plus 1 times x minus 5. Put 2 in for x. Y equals negative 2 plus 1 times 2 minus 5. Two plus 1 is 3, so y equals negative 3 times 2 minus 5 is negative 3. 3 times negative 3 is negative 9, times a negative is a positive 9, so y equals 9. So our vertex is x equals 2, y equals 9. We want to plot that point on our graph, so it'll be right here. Last, we want to find and plot the y-intercept. Y-intercept is always when x equals 0. So again, use our equation, but we're going to substitute the 0 in for x. Y equals Negative 0 plus 1 is 1. 0 minus 5 is negative 5. Negative 1 times negative 5 is positive 5. So our y-intercept is 0, 5. Go up to the graph, go to 0, 5, plot that point. Using our line of symmetry, we know that the reflection of that point would be right here. Same distance away from the line, 2 spaces, and at the same height. All right? We want those 2 points on our graph. Then we can connect them. We have 5 nice points that allow us to make a very nicely shaped parabola. One last example for you guys. Graph the function y equals the sum of x times the difference of x and 3. So y equals a times x minus p times x minus q. A, there is no a, which means a is 1, which is positive, so our graph is going to open up. X plus 2 is not written as subtraction, so we have to write that as x minus negative 2, and then x minus 3 is okay. P is negative 2, and Q is positive 3. Identify and plot the x-intercepts. These right here are your x-intercepts. So we have negative 2, 0, and 3, 0. Plot those on our graph. They should be on your x-axis. Find and graph the line of symmetry. Our equation for that, in this case, is x equals p plus q divided by 2. P is negative 2 plus q is 3 divided by 2. Negative 2 plus 3 is 1 divided by 2 is 1/2. So our axis of symmetry is 1/2. That can happen. It can be a fraction. 1/2 is between 0 and 1. So right here, draw as straight of a line as you can at that point. Find and plot the vertex. Vertex is on the line of symmetry, so we use x equals 1/2 and then solve for y using our equation. So y equals x plus 2, so we'd put 1/2 plus 2 times x minus 3, so 1/2 minus 3. 1/2 plus 2 is 2.5, or we could say 2.5. And 1/2 minus 3 would be negative 2/2, or we could say negative 2.5. 2.5 times negative 2.5 is negative 6.25. So our vertex is at 1/2, or 0.5, not times, 1/2 negative 6.25. So we'd go to negative 6.25, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Negative 6.25 would just be a little bit lower than negative 6. Do your best to estimate the point. Find and plot the y-intercept. Y-intercept is when x equals 0. Solve for y. Put 0 into our function. Y equals x plus 2, so 0 plus 2, times x minus 3, so 0 minus 3. Y equals 0 plus 2, which is 2, times 0 minus 3, which is negative 3. So y would equal negative 6. So our y-intercept would be 0, negative 6. 0, negative 6 would be right here. Based on our line of symmetry, we have another point right there. Connect the 5 points. And we have a nice parabola-shaped graph. All right, that's all the notes I have for you. Reminder, take your 10.2 extension notes quiz for practice. Do not forget to take that. That'll prepare you and get you ready to come to class. Thank you for watching this video, and please subscribe to my YouTube channel.